Okay, question 4 and 5 is asking us to classify a system of linear systems and then describe the number of solutions. So to recall before we actually do the problems, when we have different slopes, two lines have different slopes, they have to intersect somewhere. We'll get exactly one solution. We say that's consistent independent. Consistent meaning we get a solution. Independent meaning we have different lines. The second possibility is that we get infinitely many solutions. In that case, we have the same slope and same y-intercept. Again, that's considered consistent because we have a solution. Actually, we have many solutions, but we say those lines are dependent. And then the third possibility is we get no solution. Okay, we have the same slope but different y-intercepts. That's considered inconsistent because we don't get a solution. Okay, so as we take a look at problem number 4, let's go ahead and do this. As I've indicated before, anytime you have an equation and you can divide the entire equation by a number, do so. It makes your life much easier. So the second equation, I see I can divide every term by 3. And when I do that, 15x divided by 3 will give me 5x, and then 3 divided by 3 will give me 1, so I'll have a negative y, and then negative 9 divided by 3 will give me negative 3. But now notice here, okay, I have the same equation for both. And so something tells me that this is going to be infinitely many solutions, same equation, same slope, same y-intercept. So what I'll do is I'll solve the top equation or bottom. It doesn't matter, they're both the same. I'll solve it for y. So 5x minus y equals negative 3. Okay, subtract 5x from both sides. I get negative y is equal to negative 5x minus 3. Now multiply both sides by negative 1. I get y is equal to 5x plus 3. And if I did that to the second equation, I'd get the same y-intercept, or same slope and same intercept. So y is equal to 5x plus 3. So number 4, we have consistent dependent solutions, our system with infinitely many solutions. Okay, so that was number 4. Let's go ahead and take a look at number 5 here. So we'll do number 5 and see what we get. So number 5, we have 8x plus 12y equals 60, and then 2x plus 3y equals negative 24. So again, always look to divide an equation by a number if you can. It makes your life much easier. It's a lot easier working with smaller numbers than larger numbers. So the first equation I see, I can divide, well, my terms are 8, 12, and 60. My largest factor is 4. So 8x divided by 4 will give me 2x, and then 12 divided by 4 will give me 3y, and then 60 divided by 4 will give me 15. So now notice here, okay, so when I solve for y, it looks like I'm going to have the same slope but different intercepts. So I'll solve both equations for y, and you'll see that's the case. So this equation here, and 2x plus 3y equals minus 24. Subtract 2x, you get 3y equals negative 2x minus 24. Divide both sides by 3, you get y is equal to negative 2/3 x minus 8. So that's my first equation. Okay, I'll solve this one for y. So I have 2x plus 3y equals 15. Subtract 2x, I get 3y equals negative 2x plus 15. Divide by 3, I get y is equal to negative 2/3 x plus 5. That's my second equation. So as I indicated before, we're going to have the same slope, okay, but different y-intercepts. Okay, so what we have an inconsistent system here. Inconsistent and no solution. Parallel lines. They do not intersect.